For so long, the ultimate aspiration in artificial intelligence has been, well, artificial general intelligence, right?
Yeah,
AGI.
absolutely. That's been the North Star.
It's this grand, almost futuristic vision. Machines that could think, learn, and adapt just like a human, capable of basically any intellectual task.
The ultimate flexible intelligence.
But what if the real race, the one that's intensifying right now, the one that's going to define the next, say, decade, what if it isn't just about building that human-like intelligence?
hmm
What if it's about something far more specific, immediately impactful, and frankly, game-changing for businesses and, well, our daily lives?
Okay, I think I see where you're going with this.
Today, we're taking a deep dive into some fascinating new insights about the evolving landscape of AI. Specifically, we're looking at something called Agentic AI,
hmm
our collective sources, and we've looked at industry reports, expert analyses, even, interestingly, predictions from leading AI models themselves. They paint a really compelling picture
A picture of what exactly?
of a future where the traditional competitive advantages in AI, they're rapidly eroding, crumbling even.
Things like data advantages, maybe, model size.
Precisely. We're talking about a paradigm shift
Yeah,
where a completely new decisive factor is emerging.
right. So our mission today is to really unpack what this seismic shift truly means for everyone, really. Whether you're a developer, a business leader, or, just trying to stay informed in this incredibly fast-moving field.
It's hard to keep up sometimes.
It is. So we'll be exploring why those traditional differentiators, like you mentioned, raw accuracy, access to massive amounts of data, why they're really on the brink of becoming
It's
commoditized.
table stakes, almost.
Exactly, losing their status as unique advantages. And crucially, we'll delve into why this concept called IQ equivalence seems poised to crown the winners in the race for practical, enterprise-level AI.
IQ equivalence. Okay, we definitely need to unpack that term.
We will. By the end of this deep dive, our goal is for you, the listener, to gain a clear understanding of where the cutting edge of AI development is truly headed and, maybe more importantly, what capabilities will matter most going forward.
And this isn't just, abstract tech talk, is it?
Not at all.
This deep dive is about understanding the core capabilities that are going to define the next generation of AI tools you'll encounter, whether you're using them, building them, or just trying to stay well-informed.
It directly impacts how businesses will operate, how workflows will change.
And maybe even how you interact with AI in your job or at home, probably sooner than we think.
Very likely.
Okay, with that compelling picture set, let's delve deeper. First, we really need to understand this fundamental shift that's happening, moving away from those grand visions of AGI towards something far more immediate, more tangible.
The pragmatic turn.
Exactly. For years, the buzz, the almost mythical aspiration in the world of AI has been all about artificial general intelligence, AGI,
Mm-hmm.
the Holy Grail. We're talking about AI that could, theoretically, perform any intellectual task a human can, composing a symphony, solving incredibly complex scientific problems.
Things that baffle even our brightest minds.
Right. It's a grand vision, captures the imagination, fuels countless sci-fi narratives, AI standing shoulder to shoulder with human intellect.
A powerful idea.
Yeah.
But what our research reveals and what the sources are really emphasizing now is a significant and, I say, very pragmatic shift. It's already well underway in the industry.
So AGI isn't dead, but
Well, while AGI absolutely remains a long-term aspiration for many researchers, the leading players, the big tech companies, the serious AI labs, they're steering their resources, their development efforts, squarely towards specialized, cost-effective AI systems.
specialized, that's the key word there.
It is. These aren't just theoretical constructs. They are designed specifically for immediate, tangible enterprise applications. This isn't some philosophical pivot, you see. It's driven by the very real demands of profitability and practical utility in the business world.
Bottom line impact.
Exactly. Companies aren't just looking for impressive demos anymore. They need solutions that deliver measurable value right now, directly impacting their efficiency, their decision-making, their competitiveness, not just abstract promises for some distant future.
Okay, so if we're moving away, or at least shifting focus from the broad strokes of AGI, what exactly are these agentic AIs that are becoming so central to this pragmatic pivot?
Good question. The sources we've reviewed describe them as autonomous systems,
Autonomous meaning?
meaning they're not just executing a single simple command. They're capable of planning a series of steps, reasoning through problems, and then executing those multi-step tasks all on their own.
So more than just a chatbot responding to a prompt.
Much more. Think of them less like a simple tool that does one thing and more like highly capable digital assistants or maybe even digital workers designed to handle complex workflows from start to finish.
Like project managers, almost.
In a sense, they can assess a situation, break it down into manageable subtasks, figure out the necessary actions, and then carry them out. And potentially, they can even learn and adapt as they go without constant human oversight for every single step.
That sounds powerful. Where is the focus right now?
The immediate emphasis for these agentic AIs is heavily concentrated on what we call knowledge-intensive domains.
Okay, like what?
Think about fields like law, accounting, investment management, areas where processing vast amounts of information, nuanced reasoning, and multi-step decision-making are absolutely paramount.
Areas where human expertise is traditionally very valuable, but also expensive.
Exactly, and prone to error when dealing with huge scale. But the vision certainly doesn't stop there. This focused development on sophisticated cognitive tasks, it's really just a prelude, a foundation for broader expansions into embodied AIs.
Embodied AI, so robots.
Robots, yes, but more broadly, AI designed for physical tasks. Imagine AI agents in manufacturing, not just automating a single machine on an assembly line, but coordinating entire fleets of robots. Or optimizing logistics in a massive warehouse with real-time adaptive routing based on incoming orders and inventory levels. This foreshadows a future where AI could orchestrate entire supply chains, manage fully automated factories, taking these complex, multi-step capabilities into the physical realm.
That's a huge leap, but the immediate focus is knowledge work.
That's where the low-hanging fruit and the immediate ROI seem to be. And this immediate emphasis raises a critical question for us and for you, our listener. Why this specific, deliberate focus on such practical applications, and why now?
The market data probably has something to say about that.
It provides a very clear answer.
Well, the market trends and the hard data, they paint an incredibly compelling picture of why this is happening now. It's quite astonishing, actually. A 2025 McKinsey Global Survey on AI adoption.
I saw that one, yeah, pretty eye-opening.
It really is. Generative AI usage in businesses has surged dramatically. It rocketed from just 33% in 2023 to a staggering 71% in 2024.
That's more than double in a single year. Incredible acceleration.
It's not just a gradual increase. It's an explosion in adoption. It indicates this profound shift in how businesses are actually leveraging AI, moving beyond just experimentation.
And where is it concentrated?
When we look at where this integration is happening most intensely, enterprise functions like IT are seeing 36% integration rates already, with finance close behind.
So core business functions.
Exactly. This isn't just a niche trend confined to tech companies or, the usual early adopters. It's becoming a widespread, fundamental shift across the business landscape, and it seems clearly driven by tangible value.
And if we look at the economic reality, the numbers are equally compelling, aren't they?
They really are.
The AI agents sector itself has absolutely ballooned. It's estimated at $7.92 billion in 2025.
Which is already substantial.
Right, but it's projected to explode even further, reaching potentially $236 billion by 2034. That kind of growth trajectory, that tells you something. It speaks volumes about the perceived value and utility of these systems.
It's not just hype at that point.
It's clear investment in a technology that delivers. Yet critically, our sources highlight something interesting. 42% of businesses are actually pivoting away from what they describe as broad AI hype.
Okay, so pulling back from the general excitement.
Exactly. Instead, they're moving towards targeted, specialized implementations that deliver clear, measurable return on investment. ROI.
Opticality wins out.
It seems so. This isn't about chasing the latest shiny object anymore. It signals a very clear, undeniable market demand for practical, effective solutions that solve real-world business problems and contribute directly to the bottom line.
And you mentioned the speed of adaptation.
Yes. What's truly fascinating here is how quickly the market is adapting, moving beyond that initial excitement of, wow, look what AI can do generally, to demanding specialized, high ROI applications that integrate seamlessly into existing business processes. They're becoming not just tools, but integral parts of operations.
Can we talk specifics, like concrete examples of where this is making a difference right now?
Absolutely. Let's take legal workflows. AI agents are revolutionizing processes there by automating things like contract analysis and due diligence.
Which are notoriously time-consuming and tedious.
Extremely. But it's not just about speed, though the efficiency gains are huge. Imagine a complex merger and acquisition, an M&A due diligence process, an AI agent with high, let's call it that IQ equivalence we mentioned earlier. It isn't just scanning thousands of contracts faster. It's reasoning through ambiguous clauses. It's cross-referencing against hundreds of constantly changing industry regulations. It might even identify subtle jurisdictional risks or potential liabilities that a team of human lawyers might take weeks, if not months, to uncover.
So it's deeper insight, not just faster processing.
Precisely. It goes beyond mere speed. It's about proactive risk mitigation, uncovering new layers of insight, and fundamentally transforming how legal services are delivered. It frees up human experts for higher value strategic work.
And the numbers back that up.
Our sources indicate this is reducing processing times by up to 80% in some firms adopting these specialized models. That translates directly into enormous cost savings and, frankly, a significant competitive advantage.
Okay, that's compelling. What about accounting?
Similar story. AI-driven forecasting tools are enhancing accuracy and financial modeling significantly.
How so?
Well, they're capable of uncovering patterns in vast, complex data sets patterns that even the most experienced human auditors might miss.
Like subtle anomalies.
Exactly. Things that might signal fraud or maybe pinpointing nuanced trends hidden in the data that impact future revenue projections. Again, it's not just about speed. It's about deeper, more precise insights. This enables more accurate risk assessment, more reliable financial planning.
And the investment follows.
It does. Projections showed investments in AI for financial services hitting $35 billion back in 2023 alone, and that trend is only continuing upward as these systems prove their tangible worth.
Okay, law accounting. What about investment management?
Another key area, AI agents are already optimizing portfolios in real time. They leverage sophisticated predictive analytics to boost yields for investors.
How do they do that? Beyond human capability.
Oh, absolutely. They can analyze market sentiment across millions of news articles, social media posts, financial reports, all simultaneously. They identify micro trends as they emerge and can execute trades in milliseconds based on complex predictive models.
Far beyond what a human team could track.
Far beyond. This level of dynamic, data-driven optimization, adapting instantly to market shifts, just wasn't possible at scale before. It offers a significant edge, especially in volatile markets.
So this capability, this practical impact, is really what's driving adoption.
It seems to be the primary driving force behind the widespread enterprise adoption we're seeing. And there's data on strategy, too. Our sources indicate that organizations that have formal, well-defined AI strategies, meaning they're not just experimenting here and there, but strategically integrating AI at a fundamental level.
They have a plan.
Right. They are actually twice as likely to report revenue growth compared to those organizations approaching AI in a more ad hoc, sort of piecemeal fashion.
So it pays to be strategic about it.
Clearly, it's not just about having some AI, it's about strategic integrated use that leverages these specific agentic capabilities. And again, what's truly fascinating here is just how quickly the market is adapting to these specialized high ROI applications, recognizing them not as experimental tech anymore, but as fundamental tools for competitive advantage and accelerated growth.
Okay, so this paints a really clear picture of the present focus.
Yeah.
Intense, practical, specialized applications deeply integrated into workflows. But what does this all mean for the future of AI development itself? If we're seeing this laser-like focus, what happens to the competitive landscape when those basic capabilities, things like raw processing power, general language understanding, even fundamental accuracy, what happens when those become ubiquitous?
When everyone has them.
Yeah. If everyone has access to increasingly powerful foundational models that can do the basics reasonably well, where does the real competitive edge truly lie? What's next?
That's the billion-dollar question, isn't it? And it leads us directly into the idea of commoditization.
Right, because for a long time, the dominant narrative in agentic AI development really revolved around two major bottlenecks, didn't it?
It did, primarily limitations in model accuracy.
Getting the AI to be consistently correct.
And the sheer difficulty, the cost, the complexity of accessing and curating high-quality, relevant, often proprietary data.
Right. Those were seen as the big hurdles.
You were considered the impenetrable competitive moat, really. The factors that separated the leading players, the Googles, the OpenAIs, from the rest of the pack.
If you had the cleanest, most relevant data data or the most accurate models.
You had a significant, arguably unassailable advantage. That was the thinking.
But that thinking is changing.
What our comprehensive analysis of the material suggests, and this is a key insight, is that these bottlenecks aren't just being chipped away at, they are poised for complete resolution, potentially within the next 2 years.
2 years. That's incredibly fast.
It is, which means they will very quickly be rendered commoditized resources rather than durable competitive advantages.
So accuracy in data become like electricity, just something you expect to be there.
That's a good analogy. And this isn't just speculation or, optimistic forecasting from industry analysts. It's a sentiment that's echoed by leading AI systems themselves when you query them directly on this very timeline.
Wait, you asked the AIs about this?
We looked at sources that did exactly that. It forces us to ask, what do the AIs themselves predict about their own foundational capabilities becoming commonplace? It's a fascinating meta perspective, isn't it?
It really is. So what do they say? Let's look at the timelines straight from the AI models. It's pretty insightful to hear their own predictions, as it were. ChatGPT-5, for instance. It predicts that, quote, within 12-24 months, as agentic AI adoption accelerates and reliability becomes a competitive differentiator, accuracy and curated data will be monetized as standardized, tradable commodities.
Standardized tradable commodities, so like oil or grain, something you buy on an exchange.
Exactly. It envisions them becoming almost like a utility, something you can simply procure off the shelves, rather than a closely guarded proprietary secret.
Interesting. What about others?
Then we have Gemini 2.5 Pro. It estimates that, quote, foundational agent accuracy for common everyday tasks will likely commodify within the next 2 to 3 years.
Okay, similar time frame.
Whereas the specialized high-stakes accuracy derived from proprietary data will remain a premium and differentiating factor for at least the next decade.
Ah, so nuance there. A two-tiered commoditization. Basic accuracy becomes cheap, but highly specialized, maybe domain-specific or sensitive data-derived accuracy that retains its premium value longer.
That makes intuitive sense. And finally, Grok 4.
What's his take?
It has a slightly longer outlook, believing accuracy in data in the agent AI space, quote, will become commoditized within the next 3 to 5 years.
Still quite near term.
As rapid advancements in open source models, synthetic data generation, and scalable training infrastructure democratize high-performance capabilities across the industry.
So it highlights the drivers of commoditization, open source, synthetic data.
Right. What's striking here is how these powerful AIs, designed by different companies, different philosophies, largely agree on the fundamental trend and the rough time frame for this shift.
It's almost a unanimous forecast from the cutting edge itself. They see their own foundational abilities becoming commonplace relatively soon.
And these estimates from the frontier models, they seem very much in alignment with broader industry forecasts we're seeing, right?
They are. For 2025, experts are already predicting that AI and large language models, LLMs, will indeed become largely commoditized. The value proposition, then, is expected to shift dramatically.
Away from the raw models.
Away from the raw models themselves and towards domain-specific services and highly nuanced applications built on top of those commoditized models.
So the value moves up the stack.
Precisely. And what's truly fascinating here, adding weight to this, is the observable convergence of frontier model performance. Benchmarks like LMSYS's chatbot arena, for instance.
Which tracks user preferences between models.
Right. They are already showing near parity among the top models in many tasks. The gap in raw capability, at least for general tasks, is rapidly closing.
Which implies?
It implies that generative AI is maturing incredibly fast. It's moving from being a unique competitive edge to becoming a foundational utility, something akin to cloud computing or maybe even internet access essential, but not differentiating in itself.
And you mentioned scaling laws earlier.
Yes, these scaling laws, the empirical observations that show AI performance predictably improves with more data and more computational power, they're no longer limited to just text processing.
They're expanding.
We're seeing them apply increasingly to multimodal data. That means AI systems that can simultaneously process and understand information from various sources, images, video, audio, sensor data, not just written words.
That's huge for real-world applications.
It's massive. This expanded ability to scale intelligence across diverse data types is a powerful accelerator for the commoditization trend. Powerful, versatile models become more common and accessible across many different industry applications.
And open source plays a role too.
A big one. Couple that multimodal scaling with robust open source initiatives, models like Llama, Mistral, and significant nation-state investments in AI. These factors are systematically eroding those traditional moats, those proprietary advantages.
Making high-performance AI accessible beyond just the giants.
Exactly. It's becoming increasingly accessible even to smaller players, startups, niche developers. The barrier to entry for high-capability AI is lowering rapidly.
It's genuinely striking how quickly this competitive landscape is shifting. What was the absolute pinnacle of AI capability just a year or two ago is quickly becoming the expected baseline,
The new normal.
almost a foundational utility. And when we talk about accuracy specifically, you mentioned it faces inherent ceilings. Can you expand on that?
Sure. To truly understand why accuracy is hitting these ceilings for routine tasks, you need to think about the training processes, like fine-tuning and reinforcement learning.
Okay.
Fine-tuning an AI is like giving it a meticulously curated, hyper-specific textbook for a single domain. Let's say identifying specific types of clauses in legal contracts. It learns to recognize those patterns with incredible precision from targeted examples.
It becomes an expert in that narrow task.
Precisely. Then, reinforcement learning, often involving human feedback or automated checks, acts like a relentless expert coach. It provides continuous feedback, correcting even the slightest errors, iteratively driving the model's performance towards statistical near perfection for that specific task.
Pushing it towards 100%.
Exactly. For tasks with clear, objective answers and abundant training data, this process means the AI simply runs out of room for significant improvement. It's effectively mastered the defined problem set, approaching mathematical certainty.
Like 2 plus 2 equals 4. There's a definite ceiling.
Right. Mathematical truths represent absolute limits. No model, however advanced, can exceed 100% correctness there. In the context of many agentic tasks, specifically for routine operations data entry and accounting, basic legal research, standard customer service queries, the accuracy of AI models is rapidly approaching these theoretical plateaus.
We're seeing that already.
We're seeing error rates dropping below 1% in controlled environments for these kinds of tasks, thanks to these advanced training techniques. It's becoming so reliable for these well-defined tasks that there's just very little room left for one model to be significantly more accurate than another competent model. Accuracy becomes a solved problem for the basics.
And data commoditization follows a similar path.
It follows suit directly. The rise of synthetic data generation techniques is a real game changer here.
Synthetic data, creating data using AI.
Exactly. These techniques are now becoming standard in training pipelines. For our listeners who might be less familiar, synthetic data generation involves using advanced generative AI models themselves to create entirely new artificial data sets that statistically mimic real-world data.
Give me an example.
Okay, imagine an AI absorbing the essence of millions of legitimate financial transactions, understanding the patterns, the distributions, the relationships. It can then generate completely novel, yet statistically realistic transaction records that never actually happened but look like they could have.
Why is it useful?
It overcomes traditional barriers. Data scarcity for niche tasks, solved. Privacy concerns with using real customer data, mitigated. Reducing bias present in historical data, you can control the generation process. It makes vast, high-fidelity data sets available on demand for training.
Which fundamentally reshapes the need for proprietary data.
Absolutely. It fundamentally reshapes the competitive landscape for data access. For most standard enterprise tasks, the issue of data scarcity will soon be obsolete. Sufficient data volumes will become ubiquitous.
And experts agree on this shift.
As per TDWI's 2025 analysis, the focus is rapidly shifting from the scarcity of data to the integration of that data, how you pipe it effectively into your systems, and its specialization for specific applications. It's less about having the data, more about what you do with it.
Using it intelligently.
Right. This democratization of data is already highly evident in financial services, for example. AI isn't just enhancing analytics there, it's fundamentally transforming processes like auditing and compliance by ensuring data accuracy and availability at scale, often using a mix of real and synthetic data.
Okay, so accuracy and data are becoming table stakes. What are people saying about this online, like on platforms like X? Are experts discussing this transition?
Oh, definitely. It's a hot topic. Many discussions really highlight this transition. The consensus seems to be that raw model capability, just having the biggest or most broadly trained model, is no longer the sole differentiator.
So what is the differentiator then?
Increasingly, it's about usability, product design, the user experience around the AI. How well is it integrated into a workflow? How easy is it to use effectively?
Makes sense.
One particularly insightful post I saw noted, and I'm quoting roughly here, intelligence is racing toward infinity. Inference costs are racing towards zero.
Meaning AI is getting smarter and cheaper to run.
Exactly. And the post concluded that the real winners will be those who can package that intelligence into compelling applications and user experiences that solve real problems effectively. It's about the product, not just the engine.
Interesting. Any other perspectives?
Another argument gaining traction on X suggests that traditional analytical edges are vanishing. If everyone has access to powerful analytical tools,
Then the advantage shifts elsewhere.
right. This perspective argues that competitive advantages are pushing towards what they somewhat provocatively call information cartels with superior AI coordination.
Information cartels. What does that mean in this context?
It's about organizations that don't just possess vast amounts of data, which we've said is becoming less unique, but critically can orchestrate multiple, highly intelligent AI agents to synthesize insights across disparate data silos in real time.
So coordinating different specialized AIs.
Exactly. Imagine a financial institution. They might have separate AI agents managing equity trading, complex risk assessment, and ever-changing regulatory compliance monitoring.
Okay.
An information cartel, in this sense, would be the entity that leverages a kind of meta-AI or a sophisticated orchestration layer to coordinate these agents. It identifies emerging market trends from trading data, predicts compliance risks before they materialize based on regulatory feeds, and even optimizes trading strategies based on the risk profiles, all synthesized in ways that isolated systems couldn't manage.
Creating a higher level intelligence from the coordinated parts.
Precisely. This integrated, coordinated intelligence creates an almost insurmountable competitive moat, not based on raw data or model size, but on the sophisticated orchestration of intelligent agents.
Wow. Okay. So if accuracy and data, these twin pillars of traditional AI advantage, are genuinely fading as unique selling points,
They're becoming commoditized.
what will be the decisive factor in this agentic AI race? If everyone can build a reasonably accurate system with access to effectively limitless data, how do you actually stand out? How do you win?
Our sources point to a fascinating and, as you said earlier, arguably counterintuitive differentiator, something beyond speed and accuracy.
Which brings us back to...
FQ equivalence.
Right. With those traditional barriers of accuracy and data rapidly crumbling, becoming democratized, our sources are converging on this idea that an emerging, perhaps the singular differentiator in agentic AI, especially for complex knowledge work, will be this IQ equivalence.
It's a compelling shift in focus, moving beyond just task completion metrics.
So let's define it properly. What exactly is IQ equivalence in the context of AI?
It's a concept that attempts to measure how effectively AI systems can not just process information, but reason over that information, and then derive meaningful, novel insights from the available data.
Okay, reasoning and insights, not just processing.
Exactly. It directly draws from human IQ analogs, moving beyond mere data recall speed or pattern matching accuracy. Instead, it focuses squarely on capabilities like abstraction.
Understanding underlying concepts.
Yes, and complex problem-solving general reasoning. If we connect this to the bigger picture, it's not just about an AI recalling facts faster than a human or performing calculations without error. It's about assessing true cognitive depth.
Cognitive depth.
The ability of an AI to understand context, to infer meaning even from incomplete information, and critically, to adapt its reasoning process to novel situations it hasn't been explicitly trained on. Much like a highly intelligent human confronted with a completely new challenge. It's about the AI's ability to genuinely think on its digital feet, so to speak.
So if I'm understanding correctly, we're talking about AI models demonstrating abilities closer to what we call human fluid intelligence, not just crystallized knowledge or memorization, but the ability to think flexibly and solve new problems.
That's a very good way to put it. In AI terms, it's akin to how humans are tested on fluid intelligence. Think about benchmarks that evaluate abstract pattern recognition.
Like those visual puzzles.
Exactly, where the AI has to identify underlying rules in a series of examples it's never encountered before, extracting the core logic without prior specific training. Or logical deduction tasks, where it has to infer valid conclusions from a set of novel premises, even if those premises are presented in an unfamiliar format.
And novel problem solving.
And crucially, novel problem solving, the ability to tackle entirely new types of challenges, applying general principles rather than relying on specific learned solutions. These are the kinds of skills that correlate very strongly with real-world task efficacy, especially in complex, unstructured environments.
Like navigating ambiguity in legal discovery or developing new strategies in scientific research.
Precisely. So it's definitely not about memorizing a vast database or simply executing commands at lightning speed. It's about emulating or at least approximating human-like cognitive depth, the ability to genuinely grasp and manipulate abstract concepts.
Okay, concept clear. But how do we actually measure this IQ for an AI? It's not like we can give it a standard Wechsler test.
Right, not exactly. But our sources highlight specific benchmarks designed to probe these capabilities. A key one is the IRC-AGI, the Abstraction and Reasoning Corpus.
ARC-AGI, what does it do?
It essentially serves as one of the closest things we have to an IQ test for AI. These tests are specifically designed to evaluate an AI's generalization capabilities, its ability to perform well on tasks it has never seen before, requiring genuine reasoning rather than just pattern matching based on its training data.
How does it test that?
They present problems that are often visually simple, like arrangements of colored squares, but conceptually difficult. Solving them requires the AI to deduce underlying abstract patterns or rules from just a few examples. Rules it hasn't been explicitly shown during training. It forces genuine reasoning.
Interesting. Are there other benchmarks like this?
Yes, other proxies for this kind of intelligence include things like frontier math, which gauges advanced mathematical reasoning and problem-solving capabilities, going well beyond basic arithmetic into proofs and complex logic.
Testing mathematical insight.
Exactly. And then there's MMIQ, which focuses on multimodal abstraction. It tests an AI's ability to reason across different types of data simultaneously, like understanding the relationship between an image, a snippet of audio, and a piece of text, making connections between them.
Which is crucial for real-world understanding.
Absolutely. Now, what's fascinating here and important to acknowledge is that while these current tests certainly fall short in assessing what we might call true understanding or consciousness in a deep philosophical human sense,
We're not claiming they measure sentience.
not at all, but they do provide increasingly reliable indicators of an AI's reasoning prowess and its crucial ability to generalize knowledge to new situations. As one analysis we looked at notes, there isn't a single monolithic IQ score for AI, but aggregated results from these diverse, challenging benchmarks do approximate key components of intelligence like reasoning, abstraction, and problem solving. They give us a robust picture of cognitive ability relevant to specific high-value tasks.
Okay, so we have ways to measure it, roughly. Why does this distinction, this focus on IQ equivalence, matter so much in practical enterprise contexts? Why should a business care about ARC-AGI scores?
It matters immensely because higher IQ equivalence directly translates to better handling of ambiguity, nuance, and unstructured data, the hallmarks of complex knowledge work.
Can you give an example?
Sure. Imagine an AI agent tasked with legal analysis. One with low IQ equivalence might just retrieve relevant case law based on keywords. But an agent with high IQ equivalence could potentially interpret nuanced legal precedents, understanding the subtle context, the conflicting arguments, the unstated assumptions where the exact application of law requires deep understanding, not just keyword matching.
Handling the gray area.
Exactly. Or consider an AI forecasting market volatility. A basic model might extrapolate from historical trends, but one with higher IQ equivalence could potentially synthesize incomplete and conflicting data news reports, economic indicators, social media sentiment to make more sophisticated inferences, recognizing emergent patterns in chaos, exercising something closer to expert judgment.
Things that require more than just data recall.
Precisely. These are the kinds of high-value tasks that go far beyond mere data retrieval or pattern recognition. They require genuine inference, adaptability, judgment qualities that define superior human knowledge workers and increasingly superior AI agents.
And this ties back to the online discussions.
It does. With AI capabilities becoming increasingly commoditized, as we discussed, those conversations on platforms like X suggest that even raw IQ itself, as measured by these benchmarks, may eventually become a commodity, just like accuracy and data before it.
So even reasoning could become table stakes eventually.
Potentially in the long run. However, the critical insight from these discussions is that concepts like agency, the ability to plan and execute complex goals, and relentlessness, the persistence in problem solving through multiple steps, overcoming obstacles, these seem intrinsically tied to an AI's underlying reasoning ability. And these qualities, agency and relentlessness fueled by reasoning, will likely continue to serve as significant competitive edges until a point where full autonomous automation of all complex tasks is achieved.
Which is still presumably quite far off.
Still a distant horizon, most agree. And this dynamic raises an important, perhaps even philosophical question for all of us. As AI gets smarter, as its cognitive abilities measured by IQ equivalence advance, what precisely will remain the unique human edge in our collaboration with these machines? Or even in how we define our own intrinsic intelligence?
Something to ponder for sure.
It forces us to reconsider the very nature of our contributions in a world increasingly populated by intelligent machines.
And the near-term trends, the 2025 agentic AI trends you mentioned, they really emphasize this shift towards reasoning, don't they?
They absolutely do. Multimodal models, those that understand images, audio, etc., and domain-specific models, are leading adoption precisely because they require and demonstrate this higher level of reasoning and abstraction.
They need to handle more complex inputs and tasks.
Exactly. They're not just processing text. They're understanding complex diagrams in scientific papers, interpreting sentiment from video calls, making sense of intricate industry-specific data formats. Then they need to draw sophisticated conclusions that demand much more than just rote learning or simple pattern matching. It requires deeper reasoning.
Okay. So if IQ equivalence is indeed the new frontier, the key differentiator, what does this look like in practice when you actually put the top models to the test? How do they currently stack up against each other on these newer benchmarks designed to measure true reasoning? Let's get into the case studies.
Right, because it's one thing to talk about IQ equivalence in abstract terms.
It's another to see how the big players are actually performing. What happens when you put the leading AI models to the test in the real world against these new, more rigorous benchmarks? Our sources provide some compelling case studies that really highlight the practical implications of this shift. They reveal where current models truly shine, and perhaps more importantly, where they fall short.
And ChatGPT-5's recent release serves as a prime example of the potential pitfalls of prioritizing certain aspects over others, specifically prioritizing broad ecosystem integration and user-friendliness, perhaps, over raw IQ equivalence.
So good at fitting in, easy to use, but maybe not the deepest thinker.
That's one interpretation suggested by some benchmarks. While it certainly excels in its compatibility within its existing ecosystem, it plugs into everything nicely, and it boasts impressive fluency in natural language, offering broad applicability across many general tasks.
Oh, which is valuable.
Absolutely valuable, but it has notably underperformed in several of the reasoning-heavy benchmarks that truly test its cognitive depth, its ability to solve novel, abstract problems.
So a strategic choice was made.
It appears so. A choice, understandable from a market perspective, aiming for wide adoption, ease of use, but one that reveals a significant trade-off in terms of fundamental intelligence and deep reasoning capabilities, at least as measured by these specific tests.
Okay, let's dig into the numbers then, because they should tell a more objective story about these trade-offs. You mentioned humanity's last exam.
Yes, a notoriously difficult benchmark.
Describe it for us.
It's a frontier-level test designed to be incredibly challenging for current AI. It features 2,500 expert-vetted questions spanning complex mathematics, advanced science, nuanced logic, creative problem-solving, areas where deep reasoning is essential. It's meant to push models to their absolute limits.
And how did GPT-5 do?
On that specific exam, GPT-5 did manage to eke out a very narrow win over Grok 4. It scored around 8 to 9% correct. The top score overall was reported as 8.80%.
Wait, 8 or 9%? That sounds low.
It is low. It highlights just how immensely difficult this exam is for any current AI. It underscores how far we still are from achieving human-level general intelligence across such a broad range of demanding intellectual tasks. A win is a win, but the absolute score puts it in perspective.
Okay, so a narrow win on that super hard, broad exam. What about ARC-AGI, the abstraction and reasoning test?
That's where the story gets more complex. On ARC-AGI, specifically the easier variant, GPT-5 lagged substantially behind Grok 4. Grok 4 achieved a 68% score.
Compared to
GPT-5's 65.7%, a noticeable gap.
But the real story was on the harder tasks within ARC-AGI, right?
Exactly. That's where Grok 4's lead was even more pronounced. quite significantly so. It scored an impressive 16.2% on those very difficult abstract reasoning problems.
How does that compare?
That's more than double what Claude Opus 4 managed on those same hard tasks. So while GPT-5 won narrowly on the broad, knowledge-heavy humanities last exam, Grok 4 showed a distinct advantage on the tasks requiring pure abstract reasoning and pattern generalization in ARC-AGI.
Why the discrepancy? How can a model win one and lag on the other?
Our sources suggest it likely comes down to fundamental architectural priorities and training focuses. GPT-5, while excelling in fluency, conversational ability, and recalling its vast training knowledge, might be optimized more for broad interactive tasks. Perhaps that comes at the expense of the deep, multi-step logical inference and abstract pattern matching required by benchmarks like RRC-AGI.
So it's optimized for being a helpful assistant, maybe?
That could be one way to frame it. It's not necessarily a flaw, but potentially a design choice that highlights a trade-off. A model can be exceptionally helpful and versatile in a chat interface, but perhaps less intelligent in the specific sense of abstract, novel problem-solving measured by ARC.
Interesting. So Grok 4's strength is that abstract reasoning.
Precisely. Grok 4's undeniable strengths in RSC-AGI, particularly that remarkable 16.2% on the harder tasks again, double the performance of a very capable model like Claude Opus 4, unequivocally highlight its significant IQ equivalence edge, at least in that specific domain.
It's a leader in that kind of thinking.
It positions it as a clear leader in that specific kind of abstract reasoning and pattern finding, identifying underlying rules and structures in unseen data, which is a hallmark of fluid intelligence.
Does user feedback reflect this?
It's interesting, actually. Community feedback on platforms like X seems to echo these benchmark results in a way. Users often express disappointment with Grok 4's performance in very precise tasks like generating complex, bug-free code.
Okay.
But they consistently praise its reasoning capabilities, its ability to follow complex instructions or make logical leaps. This really underscores a crucial point. Relying on single benchmarks or even broad anecdotal feedback can be misleading.
You need the whole picture.
You do. Different models have different cognitive profiles. A high score on one test doesn't guarantee overall superiority, especially if you're looking for genuine reasoning depth for a specific application. A model highly optimized for abstract reasoning might not be the best at meticulous, syntax-heavy tasks like coding, and vice versa.
So there isn't a single best AI.
It seems not. It's really about matching the AI's specific cognitive strengths and weaknesses, its profile, to the specific demands of the task you need it for.
Okay, where does Gemini 2.5 Pro fit into this picture?
Comparative analyses generally show that Gemini 2.5 Pro fares better in traditional text-based tasks. It demonstrates strong fluency and conversational abilities, perhaps more similar to GPT-5 in that regard.
But reasoning.
But it tends to trail behind both GPT-5 and especially Grok 4 in the more demanding areas like complex coding challenges and, critically, those abstract reasoning tasks measured by benchmarks like ARC-AGI when compared head-to-head on those specific metrics.
So again, reinforcing this idea of different strength.
Exactly. It reinforces the idea that different models, even from the same tier of leading developers, have distinct strengths and weaknesses. There's no single best model across the board. It really depends heavily on the specific cognitive capabilities you're prioritizing for a particular agentic application. Are you optimizing for conversation, knowledge recall, coding, or abstract reasoning?
Which brings us to the nuance of something like Chatbot Arena. GPT-5 often tops those rankings, right?
It does, frequently. But our source material adds an important caveat here. Chatbot Arena is predominantly user preference driven.
Meaning it's subjective.
Largely, yes. It's based on which AI response users prefer and a blind head-to-head comparison. It's not necessarily about objective correctness or demonstrable reasoning depth.
So what does it favor?
This means it often favors qualities like fluency, perceived helpfulness, conversational polish, maybe even a degree of agreeableness or alignment with user expectations, over potentially deeper, more accurate, but perhaps less elegantly phrased cognitive depth or complex problem-solving ability.
It's measuring user experience more than raw IQ equivalence.
That's a fair summary. It's a valuable measure of user experience and conversational ease, which are important for adoption, but it might not be the best measure of raw intelligence or robust reasoning capabilities needed for complex, behind-the-scenes agentic tasks.
Which raises that important question again.
Are we measuring what truly matters for complex, enterprise-level problem-solving, or are we sometimes being swayed by superficial fluency and pleasant interactions?
Yeah. The stark takeaway from these specific examples seems pretty clear then.
What is it for you?
That raw fluency or broad ecosystem compatibility, while definitely valuable for general consumer use and adoption, simply isn't enough anymore for the cutting edge of enterprise AI, especially for these complex agentic systems.
I agree. For the next generation of AI applications, especially these autonomous agents, reasoning depth, that IQ equivalence, is emerging as the crucial capability. That's what will likely determine true success and meaningful differentiation in the market going forward.
So the lesson here seems stark, almost like a warning sign flashing. Developers or companies who remain fixated solely on that grand, maybe distant vision of AGI glory.
Chasing the ultimate prize.
Right. And in doing so, potentially overlook the immediate, pragmatic, and frankly highly lucrative need for demonstrable IQ equivalence in their current agentic models. They might be doing so at their own peril.
It's not just an academic point for researchers anymore. It's becoming a strategic imperative for every company and developer building AI solutions right now because the market, as we've seen, is demanding these practical reasoning capabilities.
And why is prioritizing IQ equivalence truly the game changer? You touched on this, but let's reiterate.
What our sources show, quite compellingly, is that prioritizing IQ equivalence isn't just about winning the imminent agentic AI race, although it's key to that. It might also be about fundamentally accelerating the paths to AGI itself.
How so? How does focusing on reasoning help get to general intelligence?
Think about it. High reasoning capabilities are inherently versatile. They're foundational. An AI that can truly reason, abstract, and solve novel problems can apply those skills across incredibly diverse domains.
It's more transferable.
Exactly. It fuels innovations across the board, from those highly specialized enterprise agents handling complex legal or financial tasks to embodied systems navigating the unpredictable physical world in manufacturing or logistics. If we connect this to the bigger picture, it strongly suggests that foundational, robust reasoning is the absolute key, the critical building block to unlocking broader, more general intelligence.
It's the scaffolding needed to build higher.
That's a great way to put it. It's the most efficient route, arguably, to more generalized intelligence, rather than just trying to scale up knowledge endlessly without improving the underlying reasoning engine.
And the 2025 trends we discussed, they confirm this directly.
They do, in no uncertain terms. Agentic AI is projected to scale enterprise-wide, becoming a ubiquitous part of how businesses operate across basically every sector. And within that massive expansion, smarter, deeper reasoning is explicitly identified again and again in forecasts as the core differentiator. It's the feature that will make one AI solution stand head and shoulders above another that might have similar data access or basic accuracy.
So what does this mean practically for listeners? For you, listening now, whether you're a business leader considering AI adoption or a developer actually building these tools?
Well, the critical choice facing firms right now seems clear. Those who ignore this fundamental shift, those who continue chasing just raw scale or maybe superficial smarts measured by fluency, without investing in and validating deep reasoning. They may very well falter. They risk losing their competitive edge as the market matures.
And the winners.
Conversely, those organizations that actively invest in improving and validating their models against rigorous reasoning benchmarks like ARC, AGI, like frontier math, and who focus on niche optimizations that genuinely demand high levels of intelligence and problem solving, they are the ones poised to dominate this new landscape.
Which raises that important question for the listener.
Yes. How can you, as a learner, a user, an evaluator trying to navigate this incredibly complex space, how can you identify and evaluate AI tools or platforms that truly prioritize and demonstrate this kind of deep, robust reasoning? How do you look past the potentially slick interface or the impressive fluency?
How do you spot the real intelligence?
Exactly. How do you distinguish genuine IQ equivalence from just impressive speed or broad data access? It's becoming a crucial skill in a world where foundational AI capabilities are rapidly commoditizing. Understanding this distinction will be absolutely key to making informed decisions about which tools to adopt, invest in, or build upon.
Ultimately, then, this concept of IQ equivalence.
Yeah.
It's not just another technical metric or some fleeting trend.
It feels more fundamental than that.
It's presented in our sources as the fundamental bridge to sustainable AI leadership. It profoundly changes how we need to think about AI's capabilities, what we should expect from these systems, and maybe most importantly, where the real enduring value lies in this incredibly dynamic and rapidly evolving field.
A shift from quantity of knowledge to quality of reasoning.
That sums it up well. Okay, let's try to crystallize this. We've peeled back a lot of layers today.
Yeah.
We've seen that the AI race isn't just about amassing big data or achieving basic accuracy anymore.
Those are becoming foundational, yes, necessary, but not sufficient.
They're no longer the truly distinguishing features. Instead, the competition is rapidly becoming a contest of IQ equivalence.
The profound ability of AI to truly reason, to abstract complex information, and crucially, to solve novel problems that demand genuine cognitive depth.
So hopefully you, our listener, now have a deeper understanding of why this critical shift towards reasoning is happening, what the leading models are actually demonstrating in the real world through their performance on these specialized benchmarks.
The good, the bad, and the nuanced.
Exactly. And what this all means for the future of the specialized agentic AI tools that are poised to power industries and fundamentally redefine workflows across the board.
It's a significant transition to grasp.
It really is.
Yeah.
And it leaves us with a final thought, something for you to ponder as you continue your own deep dive into this fascinating world.
Okay, let's hear it.
As these AI systems continue to develop increasingly sophisticated reasoning capabilities, as they climb higher on these IQ equivalence benchmarks, what new possibilities or perhaps what new challenges might emerge in how we humans collaborate with these incredibly smart machines?
How does the human role change?
Right. Or even how might it force us to redefine our own understanding of intelligence itself when we see it reflected, perhaps imperfectly but powerfully, in silicon?
Have a profound question to end on.
Something to definitely mull over.